Here we go. So thanks for having me. It's a pleasure to be here. I was in Frankfurt today and now I just came over with the train to participate in this nice event. This talk will be about architectures, huge applications and Angular. And I am Manfred, I'm a trainer and consultant, and I'm focusing on Angular. I'm doing a lot of consultancy and workshops here in Germany, but also in other parts of Europe. Personally, I'm from Austria, but most of the time I'm spending here in Germany. I'm also part of the Google Developer Expert team, which is quite an honor, because that means that I have a direct connection to the core team, to the Angular core team, and I can ask them questions. My current product is also about Angular. It's a workshop for Angular in the enterprise. It tells you all those things that are not part of the official documentation, because when it comes to Angular in the enterprise, you have to combine Angular with other stuff. For instance, stuff for authentication or stuff to manage big systems and so on and so forth. We are doing this as a public workshop in some cities, and most of the time we are doing this as an in-house workshop on premises. I want to start this talk with a question. Who of you had the pleasure of starting a new project from the scratch? Yeah, most of you. It's quite nice. And you know, at the first day it looks like this. There is this big green thing and you have the feeling that you can do anything here. And after some weeks it looks like this. You have a first prototype, it's really cute, it is doing what it shall do, and you have a nice architecture, everything is fine, you are in love with it. But after some years, it very likely looks like this. And no, this is not me in college. This is the Frankenstein monster, you know him. This monster that has been assembled of different body parts of different people. Body parts that did not belong together. And this is very likely the case in big applications after some years, because you are integrating one technology after the other one, and so you're ending up with a big chunk of different technologies, different frameworks, libraries, and perhaps architectural styles. To prevent this Frankenstein architecture, I've brought three approaches with me. The first approach is using npm-Packages. The second approach is about using the Monorepos. And the third approach is about using micro apps, microservices, and so on and so forth. Yeah, and then at the end, I will show you some guidance how you can choose the right solution for your current project. But first things first, let's get started with npm-Packages. The idea here is that we subdivide a big application into tiny packages that can be easily maintained by a little team, and then we are just taking them and integrating them into a bigger system. And in theory, using npm-Packages is really simple. In theory, it's just about this. You have a folder with these conventions here. You have a node modules folder that contains your libraries. You have your own stuff like TypeScript files or JavaScript files or HTML files, and you have a package JSON with a lot of metadata. Metadata that shows you the name of the package or the version, for instance. This is the theory. In practice, we have also to align with the Angular package format. The Angular package format is more or less a big Google document, and this Google document tells you what you have to take care about to make your library work seamlessly together with Angular. All those things make sense. All those things guarantee that all the optimization techniques of Angular work. Optimization techniques like, let's say, ahead of time compilation or tree shaking. But the document is quite long, and when you have read through the document, if you have read about 50% of the document, you will very likely look like this guy here. You will very likely look like an owl after the forest fire, because it's that overwhelming. There are so many details in there, and perhaps you're saying, hey, I just want to create a package. I don't want to do a PhD on packaging JavaScript applications. The good message here is that since Angular 6, since this March, the Angular CLI supports creating packages. And for instance, here a nice side story. The source code for this package management has been created here in Germany. It was an open source library that is called npm-Packages, and it comes from, let me think, from Trier. A developer in Trier developed it, and then the Angular team just took this open source solution and integrated it into their application. So since then, creating npm packages is really, really easy. You can create a new application with the CLI, I think you know that, ng-new, and then you can generate a library in the middle of the CLI. That means you can subdivide your big CLI project into tinier parts, and those parts can be libraries. Those parts can also be applications. That are the two types of sub-projects. For us, for developers, the main difference between libraries and applications is that libraries cannot be executed. They can just be imported into other libraries or into other applications, and then applications can be executed. Here I'm creating a flat booking library, and in addition to that, I've also created a playground application. This is what I'm usually doing, creating a testing application for my library application that also contains some end-to-end tests or some unit tests. You can easily serve your application using ng-serve, and here you have to point to your application in question. And then when you think everything works, then you can just build your library using ng-build. And this is exactly where this new mechanism comes in, this new mechanism that combines everything down to something that aligns with the Angular package format. This is where I'm always getting bad eyes, because in the past it was so difficult to create something that aligns with the package format. Now it's just this comment. Yeah, of course, after that you can move to your distribution folder, and then you can npm publish your library. That means you will publish your library with an existing registry. For instance, the registry out there in the internet at npm-js.org or an house internal registry. By the way, when it comes to house internal registries, a lot of people are using Nexus and Artifactory today. Who is using Nexus and Artifactory? Cool, some of you. It's mainly used in the Java environment. When you are doing .NET, you will very likely use Team Foundation Server. Who is using Team Foundation Server? Okay, great. And then there is my special hero, a very lightweight Italian. He is called, I think it's a he is called Verdaccio. And I'm really a big fan of Verdaccio, because Verdaccio is that lightweight. You can easily install it using npm install, and then you can easily start it just by typing in Verdaccio. And then you have a full-blown npm registry running on your server or even on your client machine. Because it's that lightweight, it's also a good option for testing and building within containers, also for a container deployment. And you can wrap it quite easily as a Linux daemon or a Windows service. Okay, using libraries is quite easy, as you have seen, and it has a lot of advantages. One of those is you can easily distribute your source code. Just put it to the registry and your colleagues can grab it. And you get versioning for free. Every time you republish your library, you have to assign a new version. And that means your customers can decide upon whether to go with the current version or with the older one. Not everyone has to update immediately to your last version. Those are the advantages, but there are also some disadvantages, and they can be found on the next slide. They can be found here. So as it looks like, all those advantages are disadvantages at the same time. Let me elaborate on this a bit. When it comes to distribution, this is a disadvantage because it is just annoying if you have to publish everything for other people in your current project. Just think about what that means. First of all, you have to implement your library, then you have to publish your library to the registry, and then you have to switch the role. Then you are wearing the hat of the application developer. That means you have to npm install the library, you have to integrate the library into your application, and very probably you will find a bug. And then once again you have to switch roles, you have to wear the hat of the library developer, you have to fix the bug, and after you're thinking you have fixed the bug, you can republish everything, it gets a new version, and so on and so forth. So as you see here, it is really annoying to work with this when it comes to one big project. It is okay when you want to share source code with other projects, but within a project this is just overwhelming.
Did you test if npm linking works so that you don't have to publish all the time or create a new version?
Yeah, so I'm not a big fan of npm linking. The good message is it works sometimes, but it caused a lot of troubles. What I used before was just copying over the library so that I'm sure everything works, but sometimes the CLI has an issue with both with linking as well as with copying over stuff. But in some minutes I have a solution for this issue. When it comes to versioning, versioning also means you have old versions out there. And old versions means you have version conflicts. Just imagine what would happen if one part of your application would use Angular 5 and another part would use Angular 7. I guarantee you all hell would break loose in this situation. And somehow, especially when it comes to one big project, we want to force everyone into using the latest versions of everything, or at least the common version. And because of these disadvantages, some people came up with this monorepo idea, which is the second approach I want to tell you about today. A monorepo is just a simple thing. It is just a folder that contains all your sub-projects. That means you are subdividing a big application into tinier parts, and each and all of those parts goes in this projects folder, for instance. And the best thing about this is this node modules folder. Not the fact that it is here, but the fact that it is here just once. You have just one node modules folder for all your sub-projects. And this guarantees that you don't end up with version conflicts. Each and every sub-project is using the same version of Angular, the same version of Bootstrap, the same version of NGRX, and so on and so forth. Besides this, there are several other advantages. Everyone has to use also the latest version of all your libraries too, because the latest versions of the libraries are in the same repository. They can be reached using /library name. We don't end up with version conflicts because of this common node modules folder. We don't have the burden of distributing libraries within one project. Everything is in the same folder structure, and creating a new library is just a piece of cake. Just add the new folder and everything is fine. And besides this, there is a lot of experience with this. For instance, at Google or Facebook, they are using this approach very heavily for years. In addition to that, also some people in the community are using this for years. For instance, all .NET developers are using this without thinking about this. When you think about a .NET solution, a Visual Studio solution, then you see it is just a mono repository, a big solution that contains sub-projects belonging to your overall software system, and everything is checked into source control and on the other side checked out together. Also, when you are working with Eclipse, you have something like this. Who has seen Eclipse so far? Some of you. I guess some of you have been forced into using Eclipse at high school or something like this. But in Eclipse you have this notation of a workspace. And a workspace is nothing else than a big folder with projects that at least should belong together, and this is what a monorepository is. One another exciting thing about the monorepository is it is not a one-way street. You can move back and forth quite easily. Let's assume you have written this application here, and let's assume you are quite confident with it. And now another project team wants to have your validation library. In this case, you could just publish the validation library using an npm registry. And so you get the best of both worlds. You can easily use the library within your monorepo, and also other people of other projects can use it by means of the registry. This is also exactly how Angular works. Angular itself is developed within a monorepo. And this makes sure that Angular Core version 7 works with Angular Form 7, works with Angular Common 7, works with Angular Router 7. And when they have done, they are just publishing everything using npm for the rest of us. Let me show you a demonstration for this. In this demonstration, I have a very simple application. It's my demonstration application. I'm using it to show a lot of concepts around Angular. You would not imagine how many concepts you can show by just a simple CRUD-based application. You can search for flights by entering some data. Sometimes you can also find flights. And for this you have to click to search and wait for the searching results here. So it's quite easy. Let's have a look at the source code of this application. When we look into the source code of this application, then we see, get out of here, then we see a monorepo. This here is a monorepository that contains all your sub-projects, applications, as well as libraries that belong together. And one part of this monorepo is my flight API. It contains services for loading flights from the backend. One of those services is, for instance, this here, it's the flight service. It uses the HClient to get some data from this URL. It's just an ordinary data service. I won't go in depth here. One additional great thing about using libraries is this public API thing. This public API thing is somehow something like a facade. A facade that sits in front of your library, a facade that makes sure that the customer, that the consumer of the library just sees specific things. He or she shall not see all the implementation details of the library, but just the things you are exporting here. This is a great thing for architecture because it means you have a lot of flexibility. You can exchange everything behind the facade as long as the facade keeps its interface, keeps its methods, its signatures, its object structures, and so on and so forth. I think this is one big reason why using libraries is a big deal in JavaScript environments, but not only in JavaScript environments. Okay, so as you see here, I'm re-exporting my flight service. I'm also re-exporting a flights entity, a data transfer object, as you want to call it, and a flights API module. This is my API layer. Here I have also a flight application, and this flight application contains a flight booking use case with a flight search component. And here I'm just getting hold of my service by means of dependency injection. This is nothing new to you if you are used to Angular to get services using constructor injection. But the best thing about this is the import statement of this very flight service. It can be seen here. So look at this, especially at the right side of this import statement. Do you notice something?
No relative path.
Yeah, it's not a relative path. It's a mapped path. It's an absolute path. It looks like the name of a library. And this is also quite a nice thing, because that means that my source code doesn't have any assumptions about the locations of my library. And so I can move my libraries around. I can put it into an npm registry. I can put it into this monorepo. I can put it into another monorepo. My application is not interested in the physical location of my library. This gives us a lot of flexibility, of course. Of course, the compiler needs to know what this means, and for this you can jump into your dsconfig JSON. In your dsconfig JSON you have something like a path mapping. A mapping that says that everything that points to my flight API name is redirected to the public API of my flight API, to my facade that is re-exporting everything that might be interesting for the consumer. You also see here that you can easily switch to other implementations. Perhaps you can say, I want to test everything with the compiled version of my library. Or you say, hey, I have a customer that gave me some picture with nice bridges on it and the euro sign, you know these pictures. I really like them, especially the green ones. And in this case, the customer got a special implementation of this module, customer A. In this case, I just need to point to it, and everything is compiled for this customer A. Conditional compiling is nowadays a thing again, especially in the front end. I know we haven't done it for years, but in the front end it's about performance, and you can get the best performance if you decide a lot of things during the compilation. So it's quite usual nowadays. Perhaps you have seen that I'm using comments in here. I'm using comments in the middle of a dsconfig file. And I know comments are not allowed within a JSON file, but guess what? Sometimes you have to risk something. It really makes me feel alive. Yeah. No, just kidding. In real world, I would just use several dsconfig JSONs, and when compiling everything, I would point to this or that version of the dsconfig JSON.
How do you switch to packages here?
Ah yeah, good question. If I wanted to switch to packages, I just needed to remove this mapping, and then the TypeScript compiler would assume that this name here is the name of an npm package that has been downloaded that is part of your node modules folder.
So you just, if you wanted the package, you just leave it out, and if you want to use the version from the monorepo, you just map it here.
Yeah, exactly. That's the case here. And this is what gives us a lot of flexibility. Okay, so I guess we have a quite nice solution, but it can get even nicer if we use some additional tooling like Nx. Nx is an extension for the CLI. It has been written by a team that is quite well connected to the Angular team, and it gives you additional CLI commands. Most of them are about the monorepo approach. For instance, it contains a tooling that gives you a visual representation of all your dependencies. It shows you which application accesses which libraries, and also which libraries are accessing which other libraries in turn. And this is quite vital when it comes to business applications, to big applications that have to be maintained for a decade or longer. Because in such applications, you have to make sure that not everything is talking to everything else. In this case, you have a quite intermingled architecture, and an intermingled and highly coupled architecture means you cannot easily change something. If you change something here, you will very likely break something on the other side. There is also another feature, it's better than this. Everything you see here can be typed into a JSON file. And with this JSON file, you can define restrictions. You can say, this guy here is only allowed to access this guy, but not that here. And then you can automatically validate this. You can validate if someone broke the rules. And so it's a nice thing to enforce something like a layered architecture, for instance, where one layer is just allowed to access the next layer, but not other ones.
How do you validate?
Pardon?
How do you validate it? The rules.
You get a special linter rule for this. That means every time you are running TS linked, this additional rule will come up.
It comes also from the same npm-Packages.
Yeah. So they are calling it norval, which is this, this animal that lives in the water, the norval. The unicorn of the water, if you ask me. And it's also part of this. Great, so we have now a quite nice solution. It seems to be a superior solution. We are capable of subdividing a big application into tinier parts. We don't have the burden with distributing libraries. Everything is fine, isn't it? Well, as every time when it comes to architecture, this also has some disadvantages, and they can be found on the next slide. Once again, it's also a disadvantage that you have a lot of sub-projects, because most of the time they will talk to each other. And every time one sub-project is talking to another one, you have a contract. Contracts are not easy to change. If you don't believe me, try to change your renting contract in the next break, or your employment contract, or your marriage contract. You will see it is not easy at all.
No, that's a marriage contract. Break.
Yeah, it is not easy at all. You have to agree upon something new, then you need intermediate solutions, so it is a long way. It takes out a lot of agility. And this is especially the case, not only but especially, when you have several teams, several UI teams. Then you are ending up with a lot of discussions. When it comes to big organizations, those discussions are most often political discussions with hidden agendas. Perhaps you know this. It's not fun at all. It's not about that communication is a bad thing, but when you're ending up talking more to other teams than implementing something within your team, then something is wrong. In this case, maintainability is quite difficult because you are not flexible anymore, and you cannot easily change the overall architecture of the whole system as well as the framework. But this is important when it comes to enterprise software that needs to be maintained for 10, 15, 20 years. In banks, you have even more, a bigger time frame for it. Perhaps 40 years or something like this when you think about mainframe applications. No one knows what will happen in 10 years. And no one knows if the current architecture, the current technology is suitable for the use cases we have to implement in 10 years. Because of this, some people invented the micro apps approach. And this is the third approach I want to tell you about today. The idea behind micro apps is everything but new. It has been around for at least 20 years. And nowadays it is used quite heavily in the backend. The idea is not to create one big system that can do everything. Instead of this, you are creating tiny systems that are specialized on some use cases. Tiny systems that are self-contained. That means they are not talking to each other much. Of course, sometimes they need to share some data and some informations, but for this they are using loosely coupled ways of communications. For instance, REST APIs or message queues or something like this. The point here is more or less those systems should be self-contained. They also have to work if all the other things are breaking down. This approach is nowadays used microservices, and it is quite heavily used in the backend. When it comes to the front end, we can use the same ideas, then you could call it micro apps. Some people are calling them micro front ends, some people are calling them micro apps. But at the end, it's the same thing. It's about subdividing and creating self-contained systems. And of course, this comes with a lot of advantages. You don't have a lot of contracts anymore between your applications. You can separately develop them. You don't have to coordinate yourself with other teams. You can separately deploy it. When you are done, you just deploy it to the server and your customers will get it immediately. You don't have to wait until the other 7 teams are done. You can deploy when you are done. You can mix and match technologies. Each and every micro app can has its own technology stack. The best technology stack that fits to your current needs. And you can mix and match architectures. Each and every micro app can has its own architecture. So as you see here, this brings a lot of flexibility. But on the other side, in the front-end layer, we also have to think about UI composition. Because for us developers, it's a fun thing to have 50 tiny applications, to have 50 less complex applications instead of one big application. For the user, this is not fun. The user is not interested into starting 50 applications each and every morning. This would be too exhausting. That means we have to find a way to present everything as a big common thing to our customers. And one easy solution for this is going with hyperlinks. It is almost too easy to be true. But hyperlinks seem to be a quite valid technology. I mean, they have been around for 20 years now. And to be honest, I have never ever heard someone say a bad word about hyperlinks. So those seem to be quite a major thing. In this case, you would end up with several tiny single-page applications, and they will link to them all. And this approach seems to be quite a nice fit for something like product suites. Product suites like the Google Suite or like Office 365. All of them are using this approach, where you have one single-page application, which is specialized in one specific aspect. For instance, Google Maps is specialized in working with maps and routes. And when you want to use another use case, you can just switch over to it by means of hyperlinks by clicking here or there. By the way, the most important aspect of the whole presentation can also be seen on this slide. It's something I'm putting a lot of emphasis into it. It's very important for me, namely, there is a city called Steierberg in the middle of Lower Saxony, in the middle of Niedersachsen.
And it's always clouded.
Always clouded, yeah. The fun thing is my first cloud solution dealt with this village. They have, how is it called? They are measuring how much water flows to the river, and we took those measurements and put them into our cloud system. Is someone of you from Lower Saxony? Yeah, I love you people, thank you. You are the best. So this is the most important thing, please always remember this. The rest is just boring technical stuff. Yeah. So let's go on with the boring technical stuff. Hyperlinks are easy to use, but one drawback is when you are moving over to a new single-page application, you are losing your application state. And you have to load a completely new application. And this is exactly what we wanted to prevent when we invented single-page applications. The need to load something new from the server time and again. Another thing you have to take care about here is a common UI. You have to provide a way to share shared widgets like this menu item here. All your micro apps should have more or less a similar look and feel. And for this issue, web components would be a good fit. Web components are those framework-independent components that can be written with Vanilla.js or also with Angular or other frameworks, and then they can be reused with each and every other framework. It's somehow the philosophy of Java. Write once and use anywhere. The good message is 2018 is the year of the web components. Web components will this year be supported in all modern browsers. When I'm saying modern browsers, I mean every browsers but IE. But the good message is it can be polyfilled down to IE, so it will also work in IE 11 when you just include the right polyfills. That means you can use them everywhere, and so you have a proper solution for sharing widgets, regardless of which frameworks are used in the specific micro apps. Saying this, just a side note, beginning with Angular 6, you can easily write web components. There is a nice library called Angular Elements, perhaps you have heard about it, and it allows you to wrap an existing Angular component as a web component. So the browser thinks it is just an ordinary web component. If you are interested into it, I've blogged a lot of this topic, about this topic, just check out my blog. Okay, so as you have seen here, using hyperlinks, using web components can be one solution. And in some situations it's fitting, in other solutions our customers deserve something better. In some situations our customers want to have something like a shell application, a shell that can load other micro apps on demand. And for this in turn we have also some possibilities. What do you think? What is the easiest way to write an application that can load another application on demand? Think about the web, think about your possibilities. What's the easiest way to load one single page application into another one? iframe. Yeah, you're right, yeah. Someone said iframe, I don't blame you. And I'm also always getting this strange feeling in the stomach when I'm using the word iframe. I think it's not the most popular thing in web development. But on the other side, it has some real advantages. For instance, an iframe provides a high amount of isolation. Isolation means that the application in the first iframe cannot harm applications in other iframes. That means a bug here doesn't influence the application there. The layout here doesn't influence the layout there, and they cannot hack each other. To prevent this hacking is also an important thing when you provide a big application with a plugin system. I have several customers that are saying, hey, we are implementing 80% of everything, and the last special 20% are implemented by partners, by business partners that are specialized in this or that branch. And so they are just including third-party applications, and of course, they are not allowed to hack the rest of the system. So iframes are a nice solution for this, even though it's not the most popular thing in web development. Another solution here might be to bootstrap several single-page applications. That means you have one index HTML, and there you load several bundles with different applications. They can be written in different languages and different frameworks, like Angular or AngularJS or Vanilla.js. Are there any other frameworks? I don't know, I think not. I think that's all. And then you are loading them just on demand. And in both cases, I would highly recommend to consider lazy loading, to not load everything on startup, but to load the things when you need them.
But then it's curious how you do the routing.
Yeah, it's a good thing. I have a solution for this. To put it in a nutshell, you need to have something like a meta routing logic that looks, for instance, at the first URL segment to decide which application to display. And then your applications have to evaluate all the other URL segments to find out which route needs to be displayed within the activated application. That would be one approach. Welcome. But in general, what you need is something like a common API. All those applications written with different frameworks need to provide a common API to the shell. Because the shell shall not need to know all the differences about those micro apps. And for providing a common API, you could use or misuse web components, because this is what they are doing. They are providing a common API, an API that looks like the API of all the other HTML elements. And web component looks exactly like a table, like an image, like a div, like an input. It provides you attributes and properties, and it also raises some events when something interesting occurs. And this is more or less also what the shell needs to know about the micro apps. So saying this is not a typical use case for web components, but it might be fitting to wrap your micro app into a web component, because then you have this unified API for the shell. Oh, perhaps I need some power. Did I bring my power supply with me? So just give me a second. It's something I found out. Those computer stuff is working in a better way if you have some power.
You have to feed them sometimes.
Yeah, of course.
Like cookie crumbs and Coca-Cola.
Yeah, I have a lot of them here inside my keyboard. Cookie crumbs, bread crumbs, and Armdoodle and Coca-Cola. Something like this. Okay, so using this you have a unified API, and it is not that awkward as it seems at first sight, because let's be honest, an application is nowadays nothing else than a component. Think about Angular, think about all the other modern single-page application frameworks. In all those frameworks, the whole application is a big component that consists of component that in turn consists of component. And they allow for nesting, because web components are evaluated by the browser. And so you can use an AngularJS component in the middle of your Angular application. Let me show a demonstration for this. Oh, I think pizzas are arriving, so we have to hurry up. So of course now I have to speak a bit faster. Look at this example now, just kidding. This example looks like the example before, but now we have just a shell. It is just a shell that loads other self-contained applications on demand. For instance, when I'm clicking here, I'm getting what I'm calling my blue Angular client. And as discussed before, it also allows routing by looking at specific URL segments. When I'm clicking there, I'm getting another self-contained Angular application. This is my red client. One vital thing here is that all those clients also run in standalone mode. That means you can develop them independently, you can test them independently, you can deploy them independently. And after deployment, the shell is just fetching the newest version of your application and displaying it. In this case, the shell is nothing else than a browser within the browser, something that provides you this common interface to your big system.
You have to use the same style.
It's one possibility. You can use the same style. But I have also seen applications where the product manager said we cannot afford to update the style of the whole system, and so specific parts of the application look more modern than other parts. Yeah. It is not a good solution in terms of UX and usability, but you know, sometimes you have other influences. So it
has just to work.
Yeah. So it really depends upon your architectural goals, and when UX is on the top of your architectural goals, then this is a no-go. If there are other architectural goals, if there are other influences, this might be a nice solution. When I'm clicking here, then, hey, what's this? I I promise you, I don't know what this logo is about. I don't know this technology. But in my point of view, this really shows that using micro apps allows you to mix and match technologies. Every team can use the best technologies for their issues.
But basically, you load only one at a time, right? You don't load the view and the Angular at the same time.
Yeah.
In your browser.
Yeah, that's true.
Okay. That's why I wasn't sure about the routing, because I thought two applications can be loaded at the same time in the browser. Routing would be. They also go by segments.
So here I'm really using a nifty trick. The first URL segment is just for the shell, and the applications just look at everything else.
But of course, when only one is loaded in the browser, it's easier.
Yeah, cool. So mixing technologies is a thing here. You can even integrate AngularJS code. Here I've wrapped an AngularJS application as a web component, and I've loaded it into the middle of my shell. Who of you has legacy code, AngularJS code? Yeah, there's a lot of AngularJS code out there. A lot of my customers are struggling with this. But as you see here, using micro apps can be a nice approach to tackle with this. And beyond us, sometimes it's also easier than using ng upgrade, because in this case, the both worlds are not that intermingled. There are boundaries between those worlds by means of bigger components. This is what I'm calling the macro architecture. The macro architecture is about loading micro apps into the shell. It's about the glue between your micro apps. And there is also something I'm calling the micro architecture, which is this here, where you can reuse widgets from other applications. So as you see here, I'm reusing a widget from my green application. I have a widget written with vanilla.js, and here I'm using a widget from my blue Angular application. And this is because of UI integration. Of course, the drawback of this is you are creating contracts once again. So it is not easy to change anything. Those widgets need to be backwards compatible. But on the other side, sometimes this is necessary. Sometimes one use case somehow needs something from another use case, and using shared widgets is just one way to tackle with this. One way with its very own advantages as well as disadvantages. Okay, now we have a quite nice solution. We have several small and decoupled projects. We can go with our Dark-Kick teams. They can do a separate development, a separate deployment. They don't have to coordinate with a lot of other teams all the time. And they can do their own decisions in terms of technology, but also in terms of architecture. Those are advantages, and as you might imagine, there are also some disadvantages. You find them here, which is the same one more time, because all those advantages come with some consequences, as always in software architecture. And the consequences here is you are ending up with more bundles. And they are less optimized. They can include duplicate code. Let's assume you are loading 3 Angular applications in your shell. Perhaps you are loading 3 times some parts of Angular with them. Of course, you can try to share code, but then the applications are not self-contained anymore. In this case, they belong to something that is loaded into the shell before. UI consistency is also something you have to deal about, but here, as mentioned before, web components are quite a nice fit. So somehow you have to tackle with all those disadvantages. Somehow you have to know your architectural goals and to evaluate them against all those advantages and disadvantages we have seen in this presentation. And this leads me to the third part of my presentation, which is about choosing a solution. Choosing a solution is quite difficult. I've did a lot of workshops with my customers in the last month, and somehow we very often ended up in discussion cycles. Because if we are honest, every one of us wants to have all the advantages, no one of us wants to have all the disadvantages. So it was really difficult to find the right solution. And because of this, to shorten all those discussions, I came up with a decision tree. Of course, such a decision tree can never be the last word on this, but it proved to be in handy to identify a first architectural candidate. The first question I would ask you here is, do you have shared state? Do you have a lot of shared state, and does the user need to move around a lot? Does the user have to move around between different micro apps a lot? And if you say no, this is not the case, then try hyperlinks. Because in this case, you very probably have some different applications that just belong together by means of a product suite. If you say no, this is not the case, we have a lot of shared state and the user is moving back and forth a lot, then the next question is, do you have to integrate legacy applications? Something like, let's say, ASP.NET or Java Server Faces. And do you need a very strong isolation? Do you need to make sure that your third-party vendor applications are not able to hack the rest of your system? And when you say yes, then go with iframes. Saying this, an iframe is not a good fit for a public website. You will not write the next Amazon with iframes, but within an intranet applications, they are quite okay-ish. I'm seeing a lot of intranet solutions using iframes nowadays. No one, of course, is talking about it, because, you know,
We have done that too.
yeah, you will not win an architectural award with iframes, but sometimes it is suitable. And this is what architecture is about, to find a suitable solution. When you say no, no legacy stuff, we are in the new world, then the next question is, do you even need a separate deployment? Perhaps you just have one UI theme, then you might not need a separate deployment. And do you even need the mixing of technologies? And when you say, yes, I need this, big teams, different technologies, long time maintenance, then bootstrapping several single-page applications is quite a nice fit. Otherwise, go with your mono-repository. In this case, the mono-repository is the best because it gives you some way to subdivide your big application into tinier parts. And then, of course, you have to do architectural work. You have to make sure that not each and every part of your application is talking with each and every other part. I know, for some people, the word monolith is a curse. Especially the microservice guys are using the word monolith as a curse. But it don't need to be a curse. Sometimes it is just a useful way to structure your application. That's why some people coined the term majestic monolith. They say a monolith can be something that's majestic if you take care about its architecture. I've written a lot of this, about this. You find a lot of articles about this in my blog. And if you liked this talk, just check out my blog and find some additional information about this. And if you say, no, I didn't like this talk at all, check out my blog anyway. Perhaps I'm writing better than I'm speaking, who knows? So let me come to a conclusion. We have seen 3 approaches to structure a big enterprise application. The first was about packages, and packages are about reuse, code reusability between projects. We've talked about the monorepo approach, which is about structure. It's about subdividing a big application into tinier parts. And we've talked about micro apps, which is about decoupling. Not only about decoupling between projects, but also about decoupling between project teams. They need to be autarkic. For packages, you can leverage the CLI, beginning with version 6. For monorepos, you can also go with the CLI, but also with NX, this sugar dip on top of the CLI, this CLI extension. And for micro apps, you can go with hyperlinks, with iframes, and with single page applications. And one last thing here, please beware this guy. Please make sure that your next application will not become a Frankenstein monster. So, thanks for coming. Here you have my contact data. You find all my material on my blog, and if you want, join me on Twitter so that we can keep in contact. Have a nice day and thank you for coming.